Rand didn't always have an advanced drone program. In fact, it began out of desperation. His Shahed 136 isn't a normal drone. It's what's called a loitering munition. Think of it as a flying missile that can search for its target. Instead of being launched toward coordinates like a traditional missile, the drone can fly long distances, locate its target, and then crash into it. In other words, it's basically a one-way drone. Once launched, it doesn't come back. The Shahed 136 has a distinctive triangle or delta wing shape, almost like a small stealth aircraft. It's about 3.5 meters long and has a wingspan of roughly 2.5 meters. Mounted at the back is a small propeller engine, which produces the loud buzzing sound soldiers often hear before impact. Some people compare the sound to a motorcycle or lawnmower in the sky. Inside the drone is a warhead weighing around 30 to 50 kilograms. That's powerful enough to destroy vehicles, radar systems, or infrastructure. But the most surprising thing about the Shahed isn't its size or power. So how does such a relatively cheap drone work? Let's break down the engineering. Airframe design. The Shahed uses a delta wing design which has several advantages. First, it provides good stability during long flights. Second, the triangular shape allows the drone to carry fuel efficiently while keeping the structure simple. The body is made from lightweight composite materials, making it inexpensive to manufacture. Unlike advanced stealth drones, the Shahed isn't truly invisible to radar, but its small size and low altitude flight make it harder to detect. Propulsion. At the back of the drone is a small two-stroke piston engine. This type of engine is similar to what you'd find in small motorcycles or model aircraft. It's not fast. The Shahed flies at roughly 180 kilometers per hour, but it's fuel efficient, allowing the drone to travel more than 1,000 kilometers. That means it can reach targets deep inside enemy territory. Guidance systems. The drone uses GPS and inertial navigation systems. Before launch, operators program the target coordinates. The drone then navigates automatically toward that location. Some versions can also receive satellite navigation updates during flight. This means the drone doesn't require constant remote control. Once launched, it's mostly autonomous. That makes it harder to jam or intercept compared to radio-controlled drones. Launch system. Another clever feature is the launch system. Shahed drones are typically fired from truck-mounted racks. These racks can hold multiple drones at once. Operators use a rocket booster to launch the drone into the air. Once airborne, the booster detaches and the engine takes over. This allows the drones to be launched in large groups, sometimes called a drone swarm. And that's where the real strategy comes in. It's the price. Each drone is estimated to cost somewhere between $20,000 and $50,000. Compare that to modern air defense missiles that can cost hundreds of thousands or even millions of dollars. This cost imbalance is a huge part of why the drone is so effective. During the Iran-Iraq War in the 1980s, Iran was heavily sanctioned and isolated. The country struggled to buy modern weapons, aircraft, and surveillance systems. So Iranian engineers started building their own. Early drones were extremely simple. Some were just radio-controlled aircraft with cameras attached. They were mostly used for battlefield reconnaissance. But over time, Iran realized something important. Drones could give them asymmetric power. Instead of competing with expensive Western fighter jets, Iran could develop cheap unmanned aircraft that were harder to detect and easier to produce. By the early 2000s, Iran's drone program had grown significantly. One organization played a major role, the Shahed Aviation Industries Research Center. This group would later design the drone that made headlines around the world, the Shahed 136. Let's break down the history, engineering, and strategy behind the Shahed drone. The Shahed drone isn't meant to operate alone. Its true power comes from numbers. Instead of launching one expensive missile, operators can launch dozens of drones at once. This creates a problem for air defense systems. Imagine defending a city with missiles that cost $500,000 each. Now imagine 50 drones approaching that city at the same time. Even if the defense system shoots down most of them, just one drone getting through can still cause damage. This strategy is known as saturation attack. The goal isn't necessarily precision. It's overwhelming the defense system. Because the drones are relatively cheap, losing some of them isn't a big problem for the attacker. In modern warfare, this economic advantage can be incredibly powerful. The Shahed drone gained global attention during recent conflicts. Large numbers of these drones have been used to target infrastructure, power stations, and military positions. Their long range allows them to strike targets far from the battlefield. And because they fly relatively slowly and low, they can sometimes slip past radar coverage. Several countries have also started developing countermeasures. These include electronic jamming, anti-drone guns, mobile air defense systems, and even interceptor drones. But the biggest lesson many militaries have learned is this: future wars may rely more on large numbers of cheap autonomous weapons rather than a small number of extremely expensive ones. And in that new kind of warfare, drones like the Shahed could play a major role. The Shahed drone isn't the most advanced weapon in the world. It's not the fastest. It's not the stealthiest. But it proves something important. Sometimes simple engineering and smart strategy can change warfare more than the most expensive technology. A relatively cheap drone built with basic components is now forcing some of the most advanced militaries on Earth to rethink how they defend their skies. And as drone technology keeps evolving, this might just be the beginning of a new era of warfare.